Bismillahirrahmanirrahim. Exercise 7.3, question number 5. If V is a vector for which V dot I equals to 0, V dot J equals to 0, V dot K equals to 0, find V. To solve this particular question, we are going to consider unit vector I. You know that unit vector I is equal to 1 into unit vector I plus 0 into unit vector j plus 0 into unit vector k, because I is a vector with magnitude 1 and its direction is only in x along x-axis. Its y component is 0, its z component is 0. Similarly, unit vector j can be written as 0 into unit vector I plus 1 into unit vector j plus 0 into unit vector k, and unit vector k can be written as 0 into unit vector I plus 0 into unit vector j plus 1 into unit vector k. Let's start the solution. Let the vector v which we are going to evaluate be equals to vx into unit vector I plus vy into unit vector j plus vz into unit vector k. First of all, we consider v dot I equals to 0. Consider v dot I equals to 0. In place of v, write this vector vx into I plus vy into j plus vz into k. Take its dot product with the unit vector I, and I'm going to write unit vector I like this. 1 into unit vector I plus 0 into unit vector j. I'm writing the vector symbol below it. 1 into unit vector I, 0 into unit vector j, plus 0 into unit vector k, and the right hand side equals to 0. Perform this dot product, and you know that the dot product will result in Vx into 1, that is Vx, plus Vy into 0, that is 0, plus Vz into 0, that is 0, equals to 0. Result, Vx is equal to 0. Now consider V dot J equals to 0. The second result, V dot J equals to 0. In place of V, again write this vector Vx into I plus Vy into J plus Vz into K dot, and write the unit vector j like this: 0 into unit vector I plus 1 into unit vector j plus 0 into unit vector k, and the right hand side is equal to 0. Perform this dot product and the result will be equal to Vx into 0, the product of x components, 0, Vy into 1, that is the product of y components, and Vy into 1 gives us Vy, then Vz into 0, the product of z components, equals to 0, equals to 0, the result Vy equals to 0. Now take the third result, V dot k equals to 0, V dot k equals to 0. Vector V, we have taken it as Vx into unit vector I plus Vy into unit vector j plus Vz into unit vector k, and dot product with unit vector k, which is equal to 0 into unit vector I plus 0 into unit vector j plus 1 into unit vector k equals to 0. Perform this dot product. Vx into 0 gives us 0. Vy into 0 gives us 0. Plus Vz into 1 gives us Vz, and the right hand side is 0. Result, Vz equals to 0. So what do we get? We get that Vx equals to 0, Vy equals to 0, and Vz equals to 0. That is Vx is 0, Vy equals to 0 and Vz equals to 0. Result, the required vector V, hence the required vector V is equal to 0 into unit vector I plus 0 into unit vector J plus 0 into unit vector K equals to 0. That is, it is a null vector. And that is the answer.